Hey everyone, my name is Ronnie, and I will be doing the introduction to our lab presentation. The product that we chose was the Pencil Graph Gear 1000. Its intended uses include drawing, writing, and marking. Here we have a picture of common parts of a mechanical pencil. The Graph Gear 1000 is a push button type. So by pressing on the button at the end, the lead will come out on the other side through the lead sleeve. This is mostly a consumer product, since a lot of users just use it for everyday tasks. Users include students, office workers, artists. The usage, although, isn't really quantifiable since a lot of these people, different people, have different tasks. A student might have like an essay to write. Office workers might just need a scribble, just jot down numbers. And artists, well, they take their time doing their drawings. Reasons to have when compared to a wooden pencil. That Graph Gear 1000 has consistent line width without the need to sharpen. It also has lower cost effectiveness and provides greater precision and control. Now, when comparing the Graph Gear 1000 to other mechanical pencils, the Graph Gear 1000 has an easy identifiable lead type. So this is a Graph Gear 500. I don't have the 1000 yet. But on the 1000, it'll have like little divots or holes where it's filled in with a different color. And every different color corresponds to a different diameter for the lead. So let's see if I could find it here. So if the holes are filled with the color brown, the lead diameter is zero point 0.3 millimeters. If it's gray, it's 0.5 millimeters. If it's blue, it's zero point 0.7 millimeters. And if it's yellow, it's zero point 0.9 millimeters. It also has a dual action retractor, which helps from lead not breaking as easily, which will reduce your costs in the long run since you won't have to buy lead refills every so often, saving you money. And with that, I'll conclude the introduction and hand it over to my teammate. Thank you and bye bye.
Hi, my name is Cole Smith, and I'm going to be going over the customer requirements versus the engineering requirements and kind of what we've established for those for this pencil. Um, our first concern is addressing the size. We believe that the customer would want the pencil to be pencil size. And so we're specifying this by that it must be less than 150 millimeters in length, not including the eraser, because that's just not a variable that we can test for every single one to make sure that it falls within the proper size. The units that are this is just millimeters, nothing special. Um, we believe that the pencil should also, or that the customer would also want the pencil to be low weight. Um, so we're saying that it should be less than 20 grams to make it so that it's lightweight. Too heavy of a pencil can cause additional strain on the wrist and hand for prolonged periods of writing, and so we want to minimize that as much as possible. We also believe the pencil should be a durable construction. And so we're saying that it must be made out of stainless steel, which has a high yield strength, um, so that it'll last a long time and it'll be a very premium product that we sell. We also believe that the pencil should be liable or reliable, which is something that the customers wanted. And we're prefacing this by that it must have less than 0.1% failure to properly push the lead out of the tip. Um, just that way that there isn't any problems, and we'll just be doing this by extensive testing. Also, we believe that if it's a pencil, you should have an eraser, and so we're saying that we must use our one or must fit one Z21 eraser, which are which leads into the next point, which is that it should be there should be longevity to it. So they shouldn't have to worry about it being a consumable good. This should last them for a while. So one of the things for this is that the first thing to typically go out would be the eraser. So we're focusing that the eraser can be easily replaced in under 30 seconds, um, with no special tools or anything like that. Um, and yeah, just so that it's very, very user friendly and easy to use and upkeep. Also, for storage, being able to clip it or to put it away, um, the customer wants a durable metal clip on here. And so, to preface durable, our metal clip must be able to hold 5 kilograms for 3 seconds. And that's just to ensure that any proper or any shocks or anything like that might that it'll be strong enough to hold up to and that it'll last. Also, we want to make sure that we have a good pencil that it can use, um, and that it's clearly marked for what it uses. Just that way there's no mix-up or anything like that. That's what the customer wants. Sorry, saying that the mechanical pencil should have high contrast marking on it, with appropriate lead size in millimeters marked at the top of the pencil, just for easily distinguish. All of them will be at the same place, no matter the different lead size. Just that way there's that standard that we always go to for for what size of lead it uses. And then comfort. The customers want the mechanical pencil to have a very comfortable, a very nice grip feel in your hand, and so we're using knurling 30 degrees with rubber pads just to provide that grippiness, but also not too aggressive, so it feels good in your hands when you're writing with it. And then again, going back to the pencil lead and also kind of tying into longevity, it should be easy to load up the pencil, and maintain and use for long, and it should last you a while. So we're saying that it must worth our Pentel high polymer lead, and it just has to use that for whatever size, and that'll be our standard basing it off of if it works or not. Yeah, those are the engineering requirements and the customer requirements. So thank you.
Hello, my name is Max, and today I'm going to be presenting our group's failure mode and effect analysis. The 5 components that our group decided to do our FMEA on are the spring, which advances the lead stick itself, the metal clip, which attaches to things like breast pockets or briefcases and stops the pencil from rolling, the clutch or the grasper, and that holds the lead in place after it's already advanced, and the fasteners, which fasten the pencil tip / cone onto the pencil body through threading, or our pencil has 2 parts on the pencil body, and it's the threading that keeps them together. Some potential failure modes for the spring are that it could lose tension or become clogged if debris gets inside the spring, which stops it from compressing. And if that were to happen, if it were to become clogged, it would not be able to advance lead at all. And if it were to lose tension, lead may fall out freely or not advance at all. In terms of the lead itself, some potential failure modes are that it could snap or it could become jammed in the reservoir, in which case, if it snapped, you just need to put a new piece of lead in the tip. Or if it became jammed, you actually have to disassemble the pencil and get rid of the jam. For the metal clip, some potential failure modes could be that it either breaks off or it bends way out of shape, which if it were to break off, then it would no longer be able to clip onto any objects, and it may have unsafe jagged edges from the metal. And if it were to bend way out of shape, it might have a harder time clipping onto objects and it would look uglier. For the clutch or the grasper, some potential failure modes could be that it loses tension, in which case lead would just fall out freely, or it becomes misaligned with the lead, and so lead can no longer come through, in which case lead wouldn't be able to come out of the pencil. And in both cases, the pencil wouldn't be usable unless you fix the issue. For the fasteners on the pencil body or the cone tip, some potential failure modes could be that the threading becomes worn out, or that debris gets inside the threading and it becomes clogged. And if the threading were to get too worn out, then the pencil would just easily fall apart and you wouldn't be able to keep the pencil together. And if there were to become sand or other debris inside the threading, then it would be a lot harder to screw the pencil together or to take it apart. So some of our important takeaways from our analysis were that the 3 failure modes with the highest risk priority were the lead getting jammed, because it happens fairly often and it's not a huge issue, but you aren't able to use the pencil until you take it apart and get rid of the jam. The second highest was the spring losing tension over time, in which case you wouldn't be able to advance lead and the pencil would be broken, but thankfully, as long as the pencil is being used correctly, it would take a very long time for the spring to lose enough tension. And then the threading getting clogged would also make it much more difficult to take the pencil apart. But assuming you're not getting sand in the threading or anything like that, it should be pretty easy to avoid this failure mode. Thank you.